Okay, for this we're going to talk about reflection. What a reflection is it's taking an image and reflecting it or turning it across a line called the line of reflection. Much as if you look at a mirror, it's the same image except your right is now on the left side. So we flip this across this line. Okay, the first thing we need to do is we need to create a perpendicular line going through our line of reflection from each point. So I'm going to use my compass and create a perpendicular line. So how I do that, I have to make sure I create a line, an arc that goes through the line twice, and then I go ahead from each intersection and make an X out in front of my line, and then connect my point with my X. And that's going to be a perpendicular line to my line of reflection. I'm going to go ahead and do that from the bottom point also. Okay, and once again, that should be perpendicular. And what do I know about this line and this line? They're parallel, because if they're perpendicular to the same line, then they have to be parallel to each other. Now I'm not going to do it with this point because this point actually lies on the line. So when I reflect it, this point is going to stay on the line. The next thing I need to do is that this line of reflection is going to be the perpendicular bisector of this line right here. So if it's a perpendicular bisector, I need to measure how far it is from the point to the line of reflection, and then mark that same point out there and call that my new point. Okay? So if I call this A, I took that and made A prime over there on the right. I'm also going to measure down here at the bottom and copy that segment. So if this is point C, this would be point C prime. And then obviously, point B would be the same thing as B prime. Then what I can do is I can connect my 3 points, and if I did this correctly, which hopefully it's pretty close, I should end up with a similar triangle, but on the other side, the line of reflection. Okay, in this case, we have this triangle, and our line of reflection is not up against the triangle. So what I have to do is the exact same steps I did with the last triangle, except I have to do it now for B also. So what I did, I constructed a perpendicular line through the line of reflection from point A, from point B, from point C. I copied the length of point A, B, and C, and then I can connect the points. Now one of the things you may notice is that I put these little marks here. These mean that these are congruent. The line of reflection is actually the perpendicular bisector between A and A prime, and B prime, and C prime. We can also do reflections based upon the graph. So in this case, we want to reflect it across the y-axis. So our y-axis is the up and down axis right here. So what we're going to do is we're going to take our triangle, ABC, and move it to the other side of the y-axis. So A is 2 points from the y-axis, so I'm going to move 2 points to the other side and put A prime. B is 1, so I'm going to move 1 to the other side and put B prime. And then C is 3, so I'm going to move 3 on the other side and put C prime. I can now connect my points, and I have a similar triangle, except rotated on the other side or reflected on the other side of my y-axis. Okay? Now one of the things to notice with this is when I look at my points, I have -2, 4 is A prime becomes 2, 4. So what changed? Only my x's. And what changed with my x's? I went from negative to positive. So when you're reflecting across the y-axis, your points actually just change your x's from negative to positive. So this would be -1, 2. So B prime, we would change the x to a positive and keep the y the same. Is 1, 2. C is -3, 1. So once again, we're just going to change the x from -3 to +3 and keep the y the same. And that's reflecting across the y-axis. To reflect across the x-axis, we're going to do the same thing we did with the y-axis, except now we're going to go top to bottom, because the x-axis runs across horizontally. So we're going to take A. A is 4 points up, so we're going to go 4 points down to get A prime. B is 2 points up, so we're going to go 2 points down and get B prime. And then C is 1 up, so we're going to go 1 down to get C prime. Connect my points, and I have a reflected triangle. So what changed with this? So we're not changing how much we go left and right, which is our x value. So A being -2, 4, I'm still at -2, but now I'm at -4. So just like when we did across the y-axis, we only changed one of the numbers from positive to negative. So in this case, since I'm going across the x-axis, I'm changing my y values from positive to negative. And if I went the other way, I'd be changing them from negative to positive. So B is 1, 2. B prime is going to be -1, -2. Okay? If C is -3, 1, we're going to keep this -3 the same. We're going to change the 1. So it's -3, -1. And those are my points, and that's how you reflect across the x-axis. Okay, for this example, we're going to reflect across x = 1. X = 1 is a line that goes vertical through x is 1. So no matter what values of y I pick, what's x? X is always 1. Okay? So to reflect on this, we're going to do the exact same way we did with the y-axis, except we're going to go over 1. So if A is 3 points from x = 1, I have to move 3 points to the right of x = 1. So remember, our line of reflection is the perpendicular bisector for A and A prime. So if I'm going 3 to the left, I have to go 3 to the right. Same thing with B. I go 2 to the left, I have to go 2 to the right. And for C, I went 4 to the left, so I have to go 4 to the right. So just off my graph there. I can connect the dots. And I should have, once again, a congruent triangle that's reflected across now x = 1. I can do the same thing if y equals, so if y equaled -1, I could reflect it across this line, and all I'd be doing is counting how far it is from this line. So C would be up 2, so I'd go down 2. A is up 5, so I'd have to go down 5. And B is up 3, so I'd go down 3. And I'd have my reflection across y = -1.